very first thing in chapter 10, we're looking at 10.1. They're talking about square roots and perfect roots. And really, the very first thing that you're going to do is you're going to go back and talk about the perfect square roots. As much as you talk about the square roots, you're really talking about the perfect square numbers, where you're doing 1 times 1, which would equal 1. 2 times 2, which would equal 4. 3 times 3, which equals 9. 4 times 4, which equals 16. You know, just keep going down the line. You've got 25, 36, all those different numbers. So when you're talking about perfect square numbers, it's anything you can multiply the same number times itself. 1 times 1, 2 times 2, 3 times 3. You know, all the way up to 11 times 11, 15 times 15, whatever number you want to do. When you talk about doing square roots, it's basically going the opposite direction. They're saying, all right, well, now let's take this perfect square number that we have, it's here, and square root that number. So when you square root 1, basically you're going to get the answer back that you had, whatever number you multiply by itself. Square root 4, well, that's 2. If you square root 9, that would be 3. Square root 16, that would be 4. So it's going back to whatever the number was that you multiplied by itself. And I guess technically what you're doing with those numbers is, if you're doing the square root of 16, technically you're rewriting that number as 4 squared. Technically. And if you've got 4 squared, the square root and the square number are basically inverses of each other. They knock each other out. So those two things would just basically get rid of themselves, and then you're left with just the 4. The other way you can kind of think about it is if you had 16, it is 4 squared, which is 4 times 4. And with square roots, it's like the exit buddy system. That to get numbers out of square roots, you have to have an exit buddy, kind of like Finding Nemo. Before they got off the Crush. Was it Crush? Crash? What was the big turtle's name? Crush. To get off Crush, you had to have the exit buddy, right? Same thing with this one. If you're going to work on square roots, you have to have an exit buddy that looks just like you. And when you do that, well, that number gets out. So that's just another way of thinking about it. But they just have you go back and work through those. If they talk about sometimes they talk about finding a square root, because you actually could get 2 numbers here. If we were square root 64, if they say list both roots, or list all roots with an S, for that one, if you square root of 64, that'd be 8 times 8. That technically you have positive and you have a negative 8. In some of the questions, they'll ask you to list both square roots or list all square roots. That means they want 2 answers. Some of the problems, though, when we go through it, they're going to ask you for just the principal square root. And the principal square root basically is just the positive answer. And some of the questions, again, they'll tell you just to find the square root or find the principal square root. If they ask for that one, that means if they ask you for square root of 64, they just want 8 as your answer, not the positive or negative. So hopefully when we go through those problems, they should kind of specify whether they want 1 answer or 2. So they should say find the square root or find the square roots with an S so you can see everything that's there. Okay. Now, with these, kind of like we had in the earlier part, back in chapter 9, we're doing absolute value. If you had absolute value of a negative number, kind of a trick question, same thing with these. If you have square root of a negative number, say negative 81. If it was 81, it'd be 9 times 9. Square root of 81 would be 9. If it's square root of a negative number, it's going to be no solution. And the reason is that if you have a negative 81, is there any way you can take two numbers and multiply them together and get a negative answer? Couldn't, could you? Because if you said, all right, well, let's make it negative 9 times negative 9. Well, if you do a negative times a negative, that's going to make it a positive 81, right? So if you're breaking these up and trying to find your exit buddies, they have to be identical. So you can't have one that's positive and one that's negative. They both have to be identical. And for that to work, it can't be a negative 81. It'd have to be a positive 81. So if you do get square root of a negative number, just say it's going to be no solution. Any negative, if you look at it that way, would be that way. Okay. They'll also give you some square roots to do, other than just square root of 25. They may give it to you in fraction form, so it's square root of 25 over 49. They give it to you in fraction form, where you've got two numbers. You can basically just split those two numbers into where you've got the top part, you can do the square root of 25, and on the bottom part, you would do square root of 49. Okay, and for this one, we'll say simplify. They should, again, either say find the principal square root, assume all the answers are positive, so you don't have to worry about the negatives with these. So if you do square root of 25, that would be 5. If you do the square root of 49, that would be 7. Now, they put a negative in front. So if you've got negative square root of 36, that part's okay because you can almost just forget about the negative for a minute. If you do the square root of 36, that would be 6. Since the negative is in front, that part's okay. Yeah. But again, if that negative had been on the inside, that's where you just go back and say no solution. And then the other couple little things that they'll do with you, they may have you simplify a decimal number. And honestly, this is one, if they give you a decimal number, just use your calculator. If you've got square root of, now again, if it was square root of 36, it would be 6. And most people look at that and they go, well, if it's 36, that's 6 times 6, so that would be 0.06. But if you remember when you're multiplying the same numbers together, if you had 0.06 squared, 6 times 6 would be 36, but that's 0.06 times 0.06. If you look at it that way, there's 4 numbers behind the decimals here, so you'd have to wind up having 4 numbers behind the decimal there. So if you did one like this, your answer would actually be 0.6 and not 0.06. So basically just cut the amount of decimals you have in half. If you have 2 here, you only need 1 here. If they gave you a number that had 4 decimals, well, then you cut that in half, you'd only need 2 decimals with whatever the number is. But honestly, if they give you one with a decimal number, just use your calculator. Easiest thing in the world to do. Okay. And then what they'll do after that is they give you a little spin-off of square roots. They're going to tell you to use the Pythagorean theorem. Okay, before we give you numbers, let's go back and make sure you remember what the Pythagorean theorem was. The Pythagorean theorem was basically the part that said if you have a right triangle, whatever's connected by your right angle, those two sides are going to be A and B, where A and B are your two shortest sides. The side that doesn't touch the right angle, that's going to be C. And the formula to use Pythagorean theorem is it's going to be a squared plus b squared equals c squared. And again, the only catch is where c is always the longest side. And that c value is going to be called the hypotenuse. Now, A and B, size-wise, they don't really matter. They're just shorter than C. C is always the longest side. A and B, which one you do, whether A is shorter or B is shorter, it doesn't matter. It's just those are what they call the legs. Those are the two shorter pieces. But again, A and B are always connected by the right angle when you're doing a problem like this. Okay, so let's give you one with some numbers here. Now let's just pretend that's a right angle. So there's a triangle. We've got x, 10, and 24. And this is where they'll tell you, all right, find the missing side that you have here. So the two pieces connected by the right angle, those are A's and B's. And again, the order doesn't really matter, but it's 24 squared plus 10 squared equals x squared. Okay, doing 24 times 24, that is 576. 10 times 10 is 100. And once you've got these two numbers, go ahead and add them up to get to 676. Okay, and with the Pythagorean theorem, once you've got it down to x squared or whatever piece of information they give to you, whatever variable it is, and you've got x squared equals 676, to get it down so it's just in terms of x, you're going to square root both sides. And depending on your numbers, if you square root 676, think through section 1, everything should come out to be a perfect square number, which in that case would be 26. And when you squared x squared, that comes out to be just x. Okay, now if it's Pythagorean theorem, the easy check is, if that's C, that's got to be longer than the other two sides. Well, they were 10 and 24, so we're okay. Sometimes people will do that problem. They know that that's the C value that's over on the opposite side. They'll work it out, do something a little bit off. They'll come back and tell me that side's 15. And then I'll look at them like, well, can that be the longest side when this piece is 24? It's like, no. So that lets you know, if that number comes out to be 16, you got to go back and check something. May have missed a button when you punched in the calculator. May have made some simple mistake when you're going through it. Okay. The only other thing they can do with Pythagorean theorem is give you another problem, but instead of x being over here on the hypotenuse, they'll put the x on one of the short sides. So maybe have x, 9, and 15. Okay, still start with the same thing, but now these two numbers you're squaring and putting together. So you've got x squared plus 9 squared, because that's the A and the B's. Longest side, 15, square that one. Nine squared is 81, 15 squared is 225. The difference on this one is you don't have the x squared by itself because you've got the x squared plus 81. So just get rid of the 81. So you've got x squared equals 144. And again, you've got to get from x squared down to x, so then go back and square root both sides. And when you square it to 144, it comes out to a perfect square root. So then your x value would be 12. Okay, so that's them just kind of walking back through again. And that's the only two options you get. Either you have the x is missing, well, like we had the first example, and then either one of the two short sides is missing, one of the two legs is missing, and that's the only two ways you can do Pythagorean theorem and get whole number answers with these. So that's the only two options when you're setting through this part. Okay, now next thing that they'll do, they'll still work with the roots, but they'll just, instead of giving you it in symbols, they'll actually just ask you to write it out and find it. They'll tell you to find all square roots, or all real square roots. And then they'll just give you a list of numbers. Okay, so if they tell you to find all the real square roots, and the key thing is, again, they'll use put the s at the end of it, so you're all real square roots. Your square root of 49, which would be positive or negative 7. So you get the two answers for it there. Now again, I don't think online homework, I don't think with ALEKS they have that plus or minus button, so technically you'd have to do 7 and then negative 7. Okay, then they'll tell you to find all the real square roots of negative 36. So if you squared a negative number, again, not really doing anything, that's just going to be no solution. Okay, so again, just kind of you bounce around with the square roots, working with the parts. Sometimes they'll tell you, again, it's all square roots. Sometimes it's just going to be find the square root, and just know that you're talking about just the one answer that's there. And again, if they say to simplify, I think we had one like that earlier, but if they tell you just to simplify, if you're doing square root of 49 over 100, if it doesn't say find all the square roots, then just assume you're only going to find the positive part of it. So square root of 49 and then square root of 100. So that would make it 7 over 10. Okay. Still the same thing, just again, just a different wording on it, just to make sure we get all the different options they'll throw at you. They'll ask you to evaluate and give you something like this, where you've got square root of negative 8 squared. Okay. And again, for that part of it, you can think about it one of two different ways. That when you have the square root of negative 8 squared, the square root and the square will always cancel each other out. And whatever you have that's left over, in this case is a negative 8, that's going to be your answer. Now, again, you may be saying, well, I thought earlier you said that, we're not going to have negatives with the numbers. We're not, but this is one of those that if you actually spread this out, it would be negative 8 times negative 8. It would be a positive 64. And if you squared 64, it would be 8. So for that one, they're kind of hinting you in and giving you a little bit of a clue that, okay, we are doing whatever number they give into you in parentheses, that's the number you can get back out, because if you squared that negative 8, that would be a 64. So then when you squared 64, it could be a positive 8 or it's a negative 8. They're kind of telling you, all right, for this one, we're going to put the negative 8 in here, so we only want that negative answer. So when they ask you to evaluate, it's okay to have an answer, because they're kind of giving you one or the other. They're going to ask you for either the positive or the negative for that part of it. Okay, now here's one where they kind of get a little bit tricky with you. Let's go -1 to the 4th. Wait, actually, let me back up there for a minute, because this one, now to mention it here, because this is how they set this one up, because they've got -8 times -8 to get to 64, actually make that answer just a positive 8. So I was just looking at it there, because the way they set this one up, they want you to do it that way. Because it would be -8 times -8, which would be the square root of 64. And they're still just going to assume that they want you to have it, so it would be just the plain 8 there. Okay, -1 to the 4th, same thing. Same setup here. They want you to write out that -1 4 different times. And once you do the negative times the negative times the negative times the negative, it's still just 1. So if you've got 4 negatives, it's going to make it positive. And if you square root 1, they want that answer just to be 1. So that one is, again, just kind of looking at it. With the evaluate part, they actually want you to kind of space it out and actually multiply the numbers together to get it to just that one number. I was thinking in the past they'd done that where they actually had to let you just cancel those two numbers out and tell me that the answer was whatever the sign was, but I'm thinking of a different book. Okay, so they kind of use that one really as more of like a bridge to get into the next things that we're looking at. Because after this one, they're going to do one of two things. They're either going to ask you to square root a number, square root a variable. They're going to ask you to simplify the square root of x to the 24. Now, here's what you don't want to do. You don't want to go back and write out 24x's and go back and circle. I mean, you can do that, but there's a lot faster way to get there. Basically, for these, if they ask you to simplify, what you can kind of think about is, now you can think about that you've got it kind of paired together. The easy way to think about it, though, is if they give you just a variable, that square root means it's like the second root. And to get this one, you can divide the power by whatever root you're going to take. In this case, we're doing square root, so you're going to divide the variable power by the root. So for this one, you can do x, do 24, and divide it by 2. If you do 24 divided by 2, that would make it x to the 12. Because if we're doing these in square roots, you're putting everything in groups of 2. Well, if you put it in groups of 2, if you've got 24, how many groups of 2 would you have? Well, you can cut it in half, right? So you'd have 12 groups of 2. So the short way is, whatever power they give to you out here, now if it's square root, it's always understood to be 2. So if there's not a number here, it's always understood that's going to be a 2. If it's something other than 2, they'll actually put the root out there. If it was going to be the third root, if it's the third root of y to the 30th, they'll actually put a 3 out there to let you know we're talking about a third root. So for that one, it would be y to the 30 divided by 3, or y to the 10. If it was t to the 18th, then you're doing the square root of it. And again, if there's not a power here, or no, they don't tell you what the root power is out here at the index, then just assume that's a 2. So then that's 18 divided by 2. It'll just be t to the 9th. So variable-wise, it's actually a lot easier. You just take whatever number you have on the inside, and as long as it's a square root, just divide it by 2. Yeah. So once you've got a few problems with just the variables, the next thing that they'll do is they'll kind of give it to you in a 2-part. So they may do something like this, where you've got the square root of 64 and then x to the 20th. Now, here's the good thing with this one. When they ask you for some of these like this, they're going to tell you to go ahead and assume that all the variables are positive. So they go ahead and tell you, all right, we're not going to worry about the whole plus or minus on these. This part, we're just going to assume that everything that we're doing is going to be positive. So we're not going to worry about doing anything weird with the variables. Okay, and if you've got two things multiplied together with square roots, especially when you've got a whole number part and you've got the variable part, that technically it's multiplied together, you can separate those two things out, that you can make it the square root of 64, and then multiply it times square root of x to the 20th. So if you've got multiplication, you can break that up as separate parts. If you've got 5 things multiplied together, you could break it up as 5 separate problems with square roots on each one of those. So now you can do the square root of 64, which would be 8. And if you do the square root of x to the 20th, well, now you're just going to take 20 and divide it by 2. So that would be x to the 10th power. Yeah, and they can even get a little bit creative with these. It can be that you make it have the square root of x minus 5 squared. Okay, now you've still got the variable, and again, we're still assuming that's the second power. You've got x minus 5 squared, so for that one, if you think about it, it's x minus 5. It's to the second power, but now you're going to divide it by 2. So that's just x minus 5 to the first power. If it's to the first power, it's just that answer. So that would just be x minus 5. So they can give you something more than just x. If it's in parentheses, they can make it x minus 5 or x plus 3 to a power, but it's still basically the same thing as just doing a regular x. Now instead of just being x to that power, it's just going to be x minus 5 to that power. And if this had been x minus 5 to the 20th power, you would take 20 divided by 2, make it x minus 5 to the 10th. Now, they're not going to ask you to do the full method and multiply all those out, because that would take too long. But they're just trying to get you the concept that if it's something to a power, and you've got a root here, you can just divide this power by that root to simplify it down. Okay, and then the last thing they do in section 1 is most everything in the beginning part, they're doing square roots for all the parts of it. The last little bit, they're going to bump everything up and now start talking about third roots or cube roots. And if you're doing the third root of something, let's take the number we had before. Before we had the square root of 64, now we'll look at the cube root of 64. If you're doing cube roots or third roots, that means now everything is in groups of 3. So with square roots, everything you had to have 2 of the same kind. With cube roots, now you got to have 3 of the same kind. So if you've got 64, that technically to cancel this thing out, you're looking for this thing to be something to the third power. So that way the 3's would cancel each other out and go from there. So 64 is 1 if you take it and break it down. Let's 4 times 4 would be 16. Times 1 more 4 would be 4 to the third. And now that you've got 4 cubed and third root, if you took the 3 divided by 3, it would be 4 to the first power. So that one would just be a 4. If it was the third root of 125. Well, 5 times 5 is 25. Times 1 more 5 would be 125. So really we're looking at the third root of 5 to the third. And again, because you've got 5 to the third power, you can basically have it so it's 3 to the third, or 5 to the third divided by 3. So that's 5 to the first, or just the plain 5. Okay, now if you get third roots with negative numbers in there, what happens if you multiply negative 5 by itself 3 times? Well, negative 5 times negative 5 times negative 5. It's going to be negative, right? So in this case, if you do multiply a negative number by itself 3 times, you can get a negative answer. So when you're doing third roots, you actually can get negative answers here. So square roots, there's nothing you can do that's going to multiply the same number times itself and get a negative. But if you start with third roots, you can multiply the same number by itself 3 times and get a negative answer. So for third roots, negatives are okay. So that's the biggest difference when you go from square roots to third roots. Second roots, you don't get a real number answer with negatives. With third roots, you actually get an answer that you can work with. Okay. The good thing is they don't go too much as far as just numbers. They really won't go much past third root. Now they'll still they'll sneak in maybe a fourth root on you occasionally. And when they do these, they'll actually say, all right, well, instead of just doing third roots, they'll call us doing nth roots. And so for these, they'll ask you, all right, let's find the fourth root of 16. So now we're looking for the same number multiplied by itself 4 different times. So if they give you any whatever power they give to you, whatever the root is, you're looking for that number multiplied together that many times. And it's almost one of those where you just take the 16 and break it down with the old factor trees that you did way back in 7th grade, 6th grade, 5th grade. 16 would be 2 times 8. 8 would be 2 times 4. 4 would be 2 times 2. So you're multiplying 2 times 2 times 2 times 2. So 16 would be the same thing as 2 to the 4th. And once you've got 2 to the 4th power and it's to the 4th root, the 4's cancel each other out. And then you get 2 for your answer. So if they go beyond square root, they just keep getting you to realize that, okay, if it's the third root, you're looking for 3 of the same number. If it's 4th root, it's 4 of the same number. Whatever the root is that they put on the outside, that's how many of that particular number you have to find to break it down to be able to go back and simplify it. Okay, so let's do one more here. Let's do the fifth root of 32 x to the 35th. Because number-wise, the fifth root's about as far as they'll go. Now, the good thing is with fifth root, you can't get much bigger than a 2 or 3. If you get to 5, the numbers just start getting into the thousands, and they're not going to have you take numbers in the thousands and try to break them down. So with 32, if you go back and check it real quick, that's 2 times 16. And we just did 16 a minute ago that it was 2 to the 4th. So it's 32. Well, 32 would be the same thing as 2 to the 5th. It's just one more 2 we had to multiply in there. Okay, so we separate off into two parts. That you've got the fifth root of 32, x to the 35th, and again, technically that's multiplied together. So break it up in two parts. The fifth root of 32, that's the fifth root of 2 to the 5th. And again, if that's 2 to the 5th power in the fifth root, the 5's cancel. That's just a plain 2. And if you do the fifth root of x to the 35th, well, that one you can take 35 and divide it by 5. So that would be x to the 7th. So still the same thing. Now they just keep expanding that a little bit farther. You shouldn't get very many with fifth roots because the numbers just get big when you're multiplying a number by itself 5 times. So most of the time you're looking at third roots are not too bad. They'll sneak in a fourth or fifth root, but almost everything in the first section's square roots. We're doing pairs of 2s. They sneak in a few more 3s, and then there's just a very small amount of fourth and fifth roots as you're going through these. Okay, and for 10.1, that should get us to the end of that part.